Welcome back to West Virginia. And I brought my darling daughter, Ellie, because she's better at telling jokes than I am. So, Ellie, are you ready for joke of the day?
Yes. Are you?
Yes, because it is the best part of the day.
All right.
Take it away.
Did you hear about the fire at the circus?
Oh no, not at the circus.
It was intense.
All right.
all
Well
yours.
done, Ellie. You are so better at joke of the day than I am. So let's get intense with equations involving absolute value. So we need to recall what absolute value means in order to solve equations that involve absolute value. Recall that absolute value shows us the distance from zero on a number line. So in other words, if I have a number inside this absolute value symbol, then it's asking me how far is that number away from zero on the number line. Well, recall that it could be on the positive end of the number line, or it could be on the negative end of the number line. So in other words, the number that could go in there could be the positive of that number, or it could be the negative of that number. So if that's the case, in order to solve absolute value equations, let's take a look at some examples and then we'll come back in and fill in those steps. I'm going to look at this first example and I'm going to say, well, what's inside these absolute value symbols, I'm trying to figure out when I get its distance from 0 on the number line and I multiply that distance by 3, I'm going to get a 21. So I need to figure out what's going to go in there so that when I multiply it by 3, I get a 21. Well, obviously, 3 times 7 would be a 21. So that means this stuff in here is going to have a distance of 7. So what that leads me to understand is I need to get this absolute value completely by itself so that I can talk about how far it is from 0 on the number line. So that means that my first step is going to be to isolate that absolute value. I'm going to get it completely by itself. So that means I'm going to divide through by 3 on both sides, because what I do on one side of the equal sign I have to do on the other side of the equal sign. That will give me the absolute value by itself. And so now I can say, okay, all of this stuff that's inside that absolute value symbol, whatever that stuff is, it's going to have a distance of 7 from 0 on the number line. So as I look at this number line, I'm going to say, okay, this would have a distance of 7, but this as well would have a distance of 7. So in other words, all this stuff in here, that 2x minus 1, it could be a 7 or it could be a negative 7. So I have two equations that I need to solve. Either that 2x minus 1 is going to be a positive 7, or that 2x minus 1 is going to be a negative 7. And I can solve either one of those equations. I'm going to add 1 to both sides here, giving me an 8. And then when I divide by 2, I'm going to get a 4. And on this one, I'm going to add a 1 and get a negative 6. And then when I divide by 2, I'm going to get a negative 3. So here are the two numbers that I should be able to plug in right here, and then multiply by 2, subtract a 1, and then get that distance. That distance is going to come up to be a 7. So when I put the 4 in there, 2 times 4 is 8. 8 minus 2 is 7. Absolute value of 7. Sure enough, this number is 7 units from 0 on the number line, and 3 times that distance of 7 will give me 21. So this definitely works. Here, when I take the negative 3 and put it in there, 2 times negative 3 is negative 6. Negative 6 minus 1 is a negative 7. That negative 7 has a distance of 7 from 0 on the number line. So the absolute value of that negative 7 is just simply going to be a 7. And 3 times that distance of 7 will give me a 21. So this one works as well. So if we go back and we take a look at those steps, then what that means is, in order to solve my equations that have absolute value in them, first I need to get that absolute value by itself, isolate it completely, isolate the absolute value, which seems to be a pattern happening with all of our equations. If we have a rational exponent, we get the rational exponent by itself. If we have a radical in it, we get the radical by itself. If we have an absolute value, we get the absolute value by itself. This seems to be the pattern happening with all of these. But once we get the absolute value by itself, then we set it equal to that plus minus, because we need to consider both sides of the number line that will have that distance from 0, and then we can solve each of those equations. But we need to be very careful about the solutions, solve each equation, sorry. But we need to be careful about those solutions and check them because we actually could have extraneous roots. So check those solutions for extraneous roots. Clearly though, honestly, you should check every solution just to make sure it works. That should just be a rule of thumb. We shouldn't even have to say this. But we do need to be careful about the idea of an extraneous root. That, technically, mathematically, it should work. But when we plug it back in, it causes problems. So now let's take a look at this one. Once again, the idea is get that absolute value by itself so that you can start talking about how far from 0 this number is from the number line. So let's get the absolute value by itself by first subtracting 2. And then let's go through and divide by that 7, giving the absolute value of 3x, whoops, not just 3, but absolute value of 3x is going to be 2. So that means the stuff inside that absolute value, all this right in here, when I think about that number line, it's going to have a distance of 2. Well, that means the stuff could be here at a 2, or that stuff in there could be a negative 2. So the 3x could be a 2, in which case I'm going to divide by 3, and I'm going to get x equals 2/3. Or the stuff inside there could be a negative 2. In which case, again, I'm going to divide by 3, and I'm going to get x equal to negative 2/3. I do need to check both of these. So when I go back up in here, and I do a positive 2/3 times 3, well, when I plug that positive 2/3 in there, what's going to happen is, don't let the fractions scare you, because remember, they typically work themselves out. Here is my check. These 3's will cancel and I'll get absolute value of 2. 2 is 2 units from 0 on the number line. So now 7 times 2 is going to be 14. And 14 plus 2, sure enough, is 16. So I know that this is definitely going to work. Now when I plug my negative 2/3 in there, once again, those 3's will cancel and I'll have absolute value of a negative 2. But absolute value of negative 2 is still 2 because it still has a distance of 2 from 0 on the number line. So 7 times 2 is 14. 14 plus 2 is 16. It still works. Both of these are going to be solutions. All right, one more example. So remember, I need to isolate that absolute value, get it completely by itself. So I'm going to subtract 6 from both sides. That will give me absolute value of x plus 1 equal to a negative 4. And so now I'm going to set it equal to the plus minus. So I've got an x plus 1 is going to be negative 4, or x plus 1 is going to be positive 4. Now if it's positive 4, I'm going to subtract 1 and get a 3. If it's negative 4, I'm going to subtract 1 and get a negative 5. Recall, I need to check both of these. So when I go to check the negative 5 in here, negative 5 plus 1 is negative 4. Absolute value of negative 4 is 4. That 4 plus 6, and let me write this down so we can see what's happening here. Might be getting lost in all the numbers. So I'm going to check my x equals negative 5. So I'll put the negative 5 in there. Negative 5 plus 1 is a negative 4. Absolute value of negative 4 is 4. 4 plus 6 is 10. 10 definitely does not equal 2. So this is one of those extraneous roots. Check the 3. So put it in here, absolute value of 3 plus 1. 3 plus 1 is 4. But absolute value of 4, yet again, is 4. And 4 plus 6 still is not a 2. That as well as an extraneous root. So remember, when I have no solutions, what do I have? Exactly, no solution. So this is my answer, no solution. Now, some of you are great at thinking outside the box. Some of you, quite frankly, could stop right here. And you could go ahead and call it no solution right at that point. How do we know this? Exactly. Remember, this means, absolute value means distance from 0 on the number line. So what this is telling me is my distance is negative. And you know you can't have a negative distance. Distance is neither positive nor negative. It doesn't have a sign at all, but this is saying the distance is negative, which cannot happen. So right here, I could have immediately said no solution. But it's okay if you didn't get that and you went through this, you would still come up with no solution either way. This is just for those people who think outside the box and can recognize it right away. And it's okay if you can't, you're still going to get there. So hopefully this helps you with equations that have absolute value in them. And remember, the main thing here is you need to get that absolute value completely by itself. Once it's by itself, then you can start talking about the stuff that's inside the absolute value. How far is it going to be from 0 on the number line? And remembering that it can be on the negative end of the number line or the positive end of the number line, because either side is going to have that same distance from 0. So you need to consider that positive, negative. That will result in 2 equations to solve, but be sure you check both of those solutions. I hope this helps. Have a fantastic day.